Now, today's tutorial, we will do the part 3 of consolidation and settlement. Yeah, today's tutorial, we will look into the part 3 of consolidation and settlement, where we will solve problems related to rate of consolidation, which is the time. Yeah, so we look into 3 examples. In the next 1 hour, we will look into 3 examples. And the end of the session, the quiz that you need to do. At the end of today's session, there will be a quiz that you have to do, and you have to submit the answer. Yeah, at the end of today's lecture. All right. Okay. Consolidation and settlement. All right. So, lecture that some of the summary that you have to when it comes to consolidation and settlement. You have to do the kind of consolidation graph. Okay, part 1. In part 2, you have to determine the total settlement using the FCL. And now we are solving problems related to rate of settlement. In part 2, we understand that there are several equations that you use to find total settlement. Several equations that you can use to find total settlement. But the one given here, the first one is a formula that you use only if the FCL is available or FCL is plotted. Okay, so you use the first formula for FCL. In some cases, the value of the CC is given, which is equivalent to the slope of FCL. If the CC value, compression index value, is there, so that is how we have more than 2 formula to calculate the secondary, so the primary consolidation SC. Yeah. So remember these two formula. These two formula will not be given in exam or in. Okay. Remember this formula, number 1 and number 2, they will in exam or in. So please memorize and understand that. Yeah? Clear? Clear. Okay. Let's look into one problem, which is a past year question. Problem past year question. So if you think this problem is too easy for you, then meaning that you have understood the course well. Yeah. So look at this problem. Yeah, look at this figure. In this figure, there are 2 columns. In this figure, there are 2 columns, column A and column B. Column A and column B. Both columns are square column, meter times 5 meter. And then they are supporting load of 780 kilonewton. And during the construction, they are buried below the ground 1 meter below the ground. So you can that 1 meter for column A, 1 meter for column B. Now, what is the special thing about this case is that you look into the thickness of the yeah. You look into the thickness of sand in column A and thickness of the clay in column A and B. They are not similar, different thickness, yeah. So probably the calculation will be different because they have different thickness of sand, different thickness of clay. Yeah? And in the layer, you can see that the initial void ratio 0.65 and the compression index is 0.68. Therefore, since the compression is 0.68, you don't need the FCL. You don't need the FCL, yeah? You formula to find SC because the CC compression index is given, height of the clay thickness, E naught is given, load current stress is not given, you have to calculate, and the effective overburden pressure is calculated. Okay, so we use the second. Why we use the second formula? Because the compression index is given. When we use the first formula, when F is available. So please be reminded. Yeah. Okay. So in this case study, what you are requested to do is first determine if stress increment. What is the stress increment at A? What is the stress increment at B? Then, what is the total settlement at A? And what is the total settlement at point B? After you know the total settlement, you can calculate the differential settlement, beza settlement at point A and settlement at point B. What is the difference? Yeah, the at point A and settlement at point B. So these are the two questions that you are requested to find. How you solve this problem? Again, we go back to this flow. Okay. Again, we go back to flow. Every time you problem related to condensation settlement, remember this flow. Remember this flow. Plot L. The SCC is not given. If CC is not given, if CC is given, compression index is given, you don't have. Then calculate the stress increment using instance chart and calculate the total stress. If you use the FCL, then you solve using the first. If you do not use FCL, then you use the second formula. So this is the flow chart or flow diagram to solve problem related to settlement and consolidation. Now, you see that 2 points. Yeah. There are 2 points. Column A, there are 2 points, column A and column B. Therefore, to make it easier and so you are not getting confused, we prepare table like this. Okay, we prepare table like this. Point A and point B. What is the initial overburden pressure at point A? What is the initial overburden pressure at point B? What is the increment using influence chart at point A? What is the stress increment using influence chart? You can total these two to the value of stress. So after you know P, you insert P into this equation. You insert the value P into this equation. Then you can solve everything. Yeah, you can find the at point A, settlement at point B, and you can compare and find the difference between the two columns. Yeah, between the two columns. So easy. Yeah, is if I give you this question in exam, make sure you know as easy as this. Okay. First, look to column A and look into column. How do you determine the overburden pressure? Remember, effective overburden measured at the middle of clay. This is where student will fail. This is where most students will make. All right. Effective overburden pressure measured before construction at middle of the clay is using the following equation. 4 times sand, 4 meter times sand, because sand is 4 meter for column A. Okay. In the thickness of the sand is 2.4 meter. Okay, 2.4 meter. Therefore, of the clay in point A is 1 meter, because we want the effective overburden pressure at the middle of the clay divide by 2. At the middle of the clay, so 1.2 divide by 2. Same goes to point B. The thickness of the clay is 2.8. Because we want to find effective overburden pressure at the middle, therefore, thickness of the clay 2.8 is divided by 2. Yeah? All right. So you can see that the effective overburden pressure for point A is 80.8, and effective overburden pressure at point B is 67.2. All right. So we managed to solve the P naught. Yeah, P naught. Pay attention. The most mistake made by student in this step is middle of the clay. They forget to divide the thickness of the clay into 2. Yeah. If you have moisture or water, then you have to minus the water. In this case, there is no water, so you don't have to minus any thickness of water. Yeah. Okay. Next, after you find P naught, what you have to do? Calculate the stress increment. Calculate the stress increment. For stress increment, the formula is net pressure equivalent to load over area minus excavation. Load over area minus excavation. So, in this case, you have to imagine during the construction. During the construction, what is the depth of the soil that you have to dig or excavate? You have to minus with the load. You have to minus with the load. So in this case, load is 7,780. Area is 1.5 times 1.5. Okay, area is 1.5 times 1.5. And then the excavation is the thickness of the soil that need to be excavated. So 1.0 meter times the unit weight of the soil, which is 17.5. Therefore, the net pressure is 329 for both column A and column B. 327.29.17 for column A and also for column B. This is the net pressure. This is not the stress increment. This is net pressure. If we want to calculate the stress increments, we have to find the influence factor times 4. Kenapa times 4? Because we have to divide your rectangular or square foundation into 4. Yeah? So that is why you have to 4 times influence factor. Yeah? Baru you multiply with 3 to 9.17. This is the stress increment. Okay? So in order for us to find the influence factor, you look into the figure. You look into the figure, you can see that there is a depth Z that you have to determine. Yeah? Z that you have to determine. Z, the value of Z is from the base. From the base, not from the top, yeah, from the base, dari tapak. This is also where students make mistake. From the base of the foundation to the middle of the clay. So this is your value of Z. The Z is important when we want to calculate or determine the influence factor. So how? Influence factor is dividing the square into 4. Because the square size is 1.5 meter times 1.5 meter. If we divide into 4, why 4? Because we want to find the stress at the corner. At the corner, therefore, each small square has a dimension of 0.75 meter and 0.75 meter, meaning that A and B equivalent to 0.75 meter. A and B is equivalent to 0.75 meter. Yeah? So, how do we use influence coefficient? In order for you to determine the influence coefficient, the step is easy. Find the Z. A is 3.6. For B is 2.8. Remember, Z is measured from the base. From the base. Dari tapak. Bukan dari atas tanah. Dari tapak. Not from the top of the soil, but from the base of your foundation to the middle of the clay. All right. So now we know Z. Now we know the width and the length of the foundation. So we can use the value to find M and to find N. What is the formula for N? Length divided by the Z, yaitu 0.2. What is the formula for N? Base or breadth divided by length, which is 0.2. If you use the chart, if you know how to use the chart, look into 0.2 and 0.2. You can see that the influence chart is 0.18. 0.018. If your M is 0.3 and 0.3, your influence chart is 0.037. So this is how do you find the influence factor. Yeah. So this rectangular area table is given in exam. Test also given. You know how to read the influence coefficient from the table. Yeah. Now we go back to the table. We already influence factor 0.18 and already know influence factor for B, 0.037. Therefore, we can calculate stress increment, yaitu 4 times 0.018 times 329.17, 20.7 kilonewton meter square. In point E, 4 times 0.037 times 329.17, which is equivalent to 48.71 kilonewton. You can see the stress increment at point B is 40, yeah, different stress increment to the value of Z, due to the value of Z. So therefore, what next? We already know P naught, which is the initial overburden pressure, 80.8. Now we have the stress increment 23.7. Therefore, the total untuk P adalah 83.5. Same goes for B. The total for 67.2 and 48.71 is 115.91. All right. So we know everything. So we can use now the formula to determine the settlement, total settlement, SC. Yeah. We have coefficient index given, compression 0.68. We have the thickness of the clay, H, 1.2 meter. We have the E naught, yaitu 0.05. So we can find the SC, yaitu 0.7 centimeter. Same goes to point B. Yeah, same goes to point B. SC is 0.27 meter or 27 centimeter. Therefore, the difference, beza, differential equation between column A and column B is 27 minus 0.7 or 26.3. So beza, this is the difference. One is higher or shorter, 26.3 centimeter than the other column. Beza dia 20 centimeter besar. Quite big the difference. Yeah. So we can use the second formula to calculate the differential equation. Okay. Any question? Any question? All right. So if you are clear, meaning that you will be able to solve test or final exam if the exam is if the equation look like this, kan? So make sure you are clear of the step. Okay. What equation to use, when to use the equation. Do not make mistake with the excavation. Do not make mistake with the value of Z. Do not make mistake with the value of Z. If you make mistake with these two, your answer will be inaccurate. Okay. Any questions so far? Okay. Tidak ada soalan? Kalau tidak ada soalan, I'll go with the second example. Okay, second example. Okay, second example as follow. Yeah. In this second example, we have to solve problem related to time factor. We have to solve problem related to time factor. Okay, so you are given the coefficient of consolidation CV. This one is This one is from the consolidation test, Casa Grande and Teller. You are given the value of the total settlement, 25 millimeter. You're given the site condition, 2.44 meter, and double drainage. Double drainage. Okay, the question is this. How long? How long? How long will it take for half of the settlement? Half of the settlement. Settlement is 25. Half of 25. How long will it take for half of the 25 millimeter to occur? This is regarding time. You need to calculate time if you are given the consolidation settlement. Yeah, number A. B, how much settlement in 1 year? So you are given time, you have to find the settlement. Reverse A and B, reverse. So this is some of the problem related to settlement. Yeah. Every time you see problem like this, remember, here is your tips, clue. Okay. Remember, if you have problem related to settlement, here's your tips. Tulis terus ini di muka surat soalan kalau kamu mau ingat. SUTVT, SUTVT. Okay, if you are given settlement, you need to find time. Use the settlement to find U from the ratio. Use U of fraction. U is fraction, yeah. Use fraction to find TV from the graph or from the chart or from the table. TV is time factor. Use time factor to find time by equation. The one on the top here, this is the equation. So this is the way you solve. Okay, the way you solve problems. So in number one, how long it take for half of the settlement to occur? Meaning that you are given you 50%. You are given you 50%. You need to find time. So use you, first use you, the one given, find factor TV, then find time factor TV, use time factor TV to find time equation. So you move to the right side from the given to the find. Yeah, remember this flow equation. Now, based on the flow equation, now you know if you are given you 50%, if you use the table, the TV value is 0.16. Use the table to get 0.196. Now, after we find TV, time factor, use the equation to find time. Use the equation to find time. Equation besar nih. Ditulis besar-besar. Okay, here, this big equation. So, masukkan all the information into the equation. We have the TV, which is 0.196. We have height of the clay 2. Why divide by 2? Because double drainage. And we have the CV. The CV value is in meter square. Remember, if the CV is in square per month, meaning that your times will be in month, your H will be in meter. In this case, the time is 18.6 months. So do not be the unit. Yeah. Okay. B. Question B. How much settlement? Okay. How much settlement that will occur in 1 year? In 1 year, how much settlement will occur in 1 year? How much? So maksudnya, you are given time. Sebelah kanan, T. You need to find settlement. Sebelah kiri, S. So use time to find TV. Use TV to find U. Use U to find settlement. Settle. Time is 1 year. We change to, kenapa we change to month? Because CV is per month. And CV is given. Therefore, we can use S on time. Okay, use the equation. Masukkan all the equation here. T, H, and C. And then use the table. If TV is 0.13, maknanya fraction 2 is 42%. Therefore, settlement is 42% times SC 25, which is 11 millimeter. So very easy. If you are given T, find TV. After T, find with this equation, as long as you follow the process. Yeah. Okay. Are we still there? All right. Okay, we are clear, right? Now, if you are clear, let's look into the last example. Here, a last example. Yeah. Okay, it is the last example. A compressible clay layer, 3 overlain by sand and gravel and by impermeable rock, meaning that the clay is single drainage. Single drainage. Okay. Given the total settlement is 11.68 centimeter, and the equation of consolidation is 5.83 times 10 minus 3 cm square per minute. Per minute. Okay. So you are given 3 questions. How long for U90? What is consolidation for times 1? And what is the consolidation? How long for 25 centimeter? Okay. So these 3 questions, again, this question like this can be solved easily using this flow equation, easily using this flow equation. How long? Maksudnya find T when U is 90, when U is given. So use U to find TV, use TV to find T. And then second one, compute the primary consolidation settlement. Maksudnya find S for 1 equivalent to, for time 1 year. So maksudnya you have time, you have to use time to find TV, use TV to find U, you get the settlement. Okay. Same goes to number 3, C. Find T when you have settlement 25. So pay attention. Make sure you use consistent unit. You use consistent unit. Jangan sekejap cm, sekejap meter. The easier way is use the CV value as your guideline in this equation. If CV is meter per month, maksudnya H must be meter, time must be month. If CV is centimeter square per minute, maksudnya H must be centimeter, T must be minute. So the unit of T and the unit of H must be consistent with the unit of CV given. Yeah, don't make mistake. Don't make stupid mistake. All right, so let's look into the solution. Number one, given U90. So, very easy. Tutup mata pun boleh. If you are given U, you have to find T, meaning that kita ke kanan. Use U90 to find time factor. From the table, dapat 0.848. Use time factor to find T menggunakan equation. So using the equation di atas, dapatlah T90, which is 35.6 at 6 year. Okay, so easy. Number two. You are given time. Find SC. So very easy. Use the equation to find TV based on the time. Jadi TV dia adalah 0.023. Because 1 year is 528,600 minit. Kenapa mau tukar minit? Because CV adalah minit. Dan H adalah 360 cm. Kenapa bukan 3.6 meter? Karena CV adalah cm square. Therefore, you can find that the settlement at 1 year is 9.99 cm. Yeah, 1.99 cm. So consistent with your unit. If you are not consistent, you are done. Okay, lastly, you have you are given the fraction U, which is settlement, which is 2.5 millimeter, 25 millimeter. Find time. So very easy. U is a fraction. So 25 millimeter is 2.5 cm. So cm, 2.5 cm to 11.6 at cm, dapatlah 21%. So your U is 21%. So from the table, 21% equivalent to 0.04 time factor. Therefore, using the equation, I can calculate the time as 1.69 year. Meaning that whenever you face problem related to the rate of settlement, always follow this SUTVT. Dan H dan T must be consistent with the unit of CV. Coefficient of consolidation must be consistent. All right? In order for us to solve this problem. So, actually, it's not that difficult, complicated, because the process is similar to whatever questions that you have to follow the same correct procedure to solve the problem. Yeah? Therefore, that is the end of our tutorial for today. I've given you 3 examples with the solution. I want you to try this question. I want you to try this question, this quiz. Find CV, find SC, find UT, and time. Given the lab data, given the site data. Given the lab data, given the site data. Yeah? Solution must be submitted. Solution must be submitted by tomorrow. Solution to this quiz must be submitted by tomorrow at the folder on ITEL. At the folder on ITEL must be submitted by tomorrow at folder on ITEL. Okay. I hope you understand everything. I open the time remaining if there is any questions from you. Any question? If there is no question, I want to give the what you call it? I want to give the attendance link. Okay, so please check the attendance link. Please give the attendance link. And your attendance. And also, lastly, I want to explain your test on next week. Because we have covered everything, there will be a test next week. Yeah. Okay, there will be a test next week. The 2-hour exam will requires you to answer 2 questions. Question number 1 and question number 2. Question number 1 is from the retaining wall design topic chapter, where you have to determine factor of safety, sliding, overturning, bearing capacity, and you must know to calculate the bearing capacity. This is question number 1. And question number 2 is quite long. You have to analyze CV, you have to plot FCL, and also solve problem related to rate of settlement, the topic that we discussed today. Yeah. Most importantly, you know how to determine stress increment from the influence chart, regardless of whether it is square or circular. You know how to determine the stress increment. Yeah. These are the topics that may come out in our test next week. Okay, so that is all for today. Thank you very much. If there is no question from you, I only wish you good luck. See you guys next Tuesday for the test. All right. Thank you very much. See you guys next Tuesday.
Thank you, Doctor.
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 Doctor.
Thank you, Doctor.